Hello, I am Cordell Palmer,
I'm Will Muscatello.
I'm Grayson.
and we are representing Team A1-4 for our prototype, the Buzzbus. So here is our Buzzbus. We came up with the name Buzzbus because it resembles the appearance of a school bus despite its orange color.
So first we have the drivetrain. We purchased the rubber wheels for the rear axle to grip the surface better while it traverses down the ramp. We found it unnecessary to purchase rubber wheels from the front because the MDF grips well enough, so we saved a little money there and cut 2 1/4-inch MDF wheels to create a 1/2-inch wheel. We used acrylic gears to transfer motor power because the alternative, which would be MDF gears, which we tried, but they slipped on the motor's axle. Basic dimensioning math was used to calculate the distance between the axle and the motor so that the gears would mesh appropriately. And we use a 2-to-1 gear ratio so we can control the robot's speed so it won't go too fast, won't go too slow. That's it for our drivetrain.
As for our chassis, we used 1/4-inch MDF with 4 mounting brackets on the bottom and 2 on the top because we had to frequently disassemble the connection between the sidewalls and bottom board. Interlocking MDF holes between the middle board and the sidewalls were selected for the same reason, and it also desirably maintained the frame of the robot, so we found it unnecessary to use screws. We maximized the robot's dimensions within the size requirement to allow the components to fit and increase the height leverage of the scoring mechanisms. It also it gave us room to prevent snags and move components around more conveniently. The Arduino was mounted roughly at the center on the top MDF board to provide convenient access to the components.
Finally, we used a lever switch to activate the scoring mechanisms because we found that other switch input methods were very not reliable. Most importantly, we noticed that the rotating platform had rectangular extensions that we could use to see where the platform was in its rotation. And we used tape to ensure contact did not move the robot at all, and it just brushed on the switch.
Our quadrant scoring mechanism features an upward sloping ramp that has a linear actuator mounted on the ramp at the bottom to fire the balls upwards. Conveniently, the extrusion of the actuator prevents double loading, which allowed us to selectively fire the balls at appropriate intervals. In previous iterations, we attached the actuator and ball holder directly to the center of the MDF board, but this actually proved to be inconsistent because the ball's trajectory was not adequately controlled, so instead we used a rectangular barrel on the ramp. 3D printing was used to manufacture the ball holder because it's smoother, and it was actually an initial iteration that we stuck with because we thought we were going to need a more complicated system.
Our mystery machine mechanism features 2 mouse traps with an arm entirely constructed of MDF hinged to a center wooden beam to allow for vertical rotation into the top hole. The balls are stored and released in a basket arm via gravity. When the arm rotates and reaches a certain angle, the balls will naturally roll out of the holder. We used a winch to lower and raise the arm. We attached a square piece to the motor to allow for manual manipulation of the arm, such as when we are resetting the robot. Additionally, the circular piece where the thread is held snapped, so we had to redesign it with collars instead of the 3D printed winch like we did in the first place.
That concludes our presentation of the Buzzbus. Thank you for listening.